Yeah, I know, it's taken us forever, but here we are. Today we have a solution for you to show you how to bring your Mavic Pro battery out of hibernation, get it charging and get it back to flying using a CP2112 debugging board. Let's show you guys how this is done. Welcome back to the channel, guys. Dave from We Buy Drones here. Yes, I know this video has been long overdue. You know how life goes, things get busy, but here we are nonetheless. So one of our previous videos, one of the first ones, we showed you guys how to revive your Mavic Pro batteries using TRB software. I'll link it up here. Yeah, you can go and have a look at that. Unfortunately, TRB is no longer available. It is also a paid license. You have to pay a yearly or monthly license to use it. But in any case, it's no longer available. But great news is we have a solution using the CP2112 debugging board and DJI's Battery Killer V2 software. Okay, guys, in one of our very first videos, I'll link it up here as well. You saw we did a multitude of batteries, but that software, V1 software, is not compatible with Mavic Pro. Okay, so it has to be the V2 software. So, guys, disclaimer. Please do not use any metal tools to pry open the casings. All right, metal tools, you could potentially puncture a cell, and if you puncture a cell, it's going to be a lot of fire and smoke. Okay, so use plastic tools. You're going to have to get the casings open. Try and do it as neatly as possible, so you can reuse the casings. Unfortunately, DJI does use a lot of glue in here, so it might be a bit of a process. But if you can get them open neatly, you can at least reuse the casings. Alright, so once that's open, you need to access the back of the BMS board, which we will show you in the video coming up now. Guys, if you do want the V2 software, stick around to the end of the video. I will explain how you can get that from us. So let's head over, without further ado, join Ashraf, and he will take you guys step for step through the process on how to get your Mavic Pro batteries charged up and ready for flight again. Let's go do it.
Hi guys, we are back with another video. As promised, we've had tons of requests for a Mavic Pro battery revival video, sort of a part 2. We have promised this video and this is the one. So I'm gonna get started immediately. Obviously this is what the battery looks like internally outside of the case. We have shown what we sort of over the process on opening one of these as neatly as possible without damaging this. There are odd occasions where you will inevitably damage these casings due to the amount of glue being used as per DJI in these little slits. Sometimes they use a ton of glue. They really do use a ton of glue. So you're lucky if you get a battery or have a battery that doesn't have too much glue in there. Anyway, let's get started with the process. A couple of things that are needed. This is a CP2112 USB reader / writer programmer, and then just a normal micro USB cable. I'm just going to get this guy ready in the meantime. You will unfortunately need a soldering iron as well. I'll show you why in a second. You would most likely need a bench power supply, and then a balance charger is sort of a nice to have. It's not necessary, but it does help. It's very helpful. It'll give you an indication, a more detailed idea of what cells and cell balancing looks like, but I will show you guys that in a moment as well. So I'm just heating up the soldering iron, and then I will show you guys the pinout so that we can actually get this BMS soldered and then powered up with the bench power supply, soldered, read on the Battery Killer software, unlocking it, the BMS, and then clearing the PF, which is a permanent failure flag, and then resealing the battery for use. All of the above mentioned is obviously entirely dependent on cell health. So if the cells are all good at PF because they're in storage, for example, as mentioned before, it is a 3-cell battery. So one of the cells ran down to say 3.3 volts, 3.2 volts. The other two cells are still at, for example, 3.5. Then it will PF. 3.5, between 3.4 3.5 is the threshold. So if it drops below that voltage, the BMS kicks in and flags it for permanent failure, because it's lipo cells. Right, so yeah, let's start with the procedure for soldering on this wiring quickly. So there is a piece of foam on the back of this board. You can just carefully pull it back. I've already made reference points to where you solder onto. So that one over there is your clock. This one over here is your data line, and then I use this ground over here usually. Any ground works, but let me just see if I can focus. That one over there is clock. That point over there is data, and then the first point on the side, you'll see it actually says C1, C2, or V1, V2, or B1, B2 at times. That would be each cell's positive connection. Okay. So we tend to use, just normal, the little female connector that can plug into our CP board. So just normal female connectors. I'm just going to cut these guys off just to get some bare wire to solder onto the BMS board. There are some batteries, obviously this is for Mavic Pro, but there are some batteries that do not need to be soldered. You actually get specialized adapters. You don't have to buy the adapters, it just makes life a lot easier. But you do get these adapters that just clip into the battery or plug into the battery itself, into the battery's charging connector, and you plug it straight into the CP. But like I said, in this specific video, we're just going to showcase what it's like for the Mavic Pro battery. I'm just going to thin the wires before I solder it on. The only concern here is to ensure you know which wire goes where. So it doesn't matter in terms of color. I mean, these are just random colors. I'm gonna, for example, use the green wire for ground, and I'll use the yellow one for the data line, and then the orange for the clock. The color, honestly, the colors do not matter. Doesn't make a difference. Another thing I usually do is I clean the adhesive, the residual adhesive around the connections. This makes the soldering a lot easier. You can see this one's cleaned up already, but I'm just giving you an idea. I mean, if you look on the side, I can just push the adhesive away fairly easily, and that's what I do around this point, around that point, and around the ground. I also leave the sponge on, this little piece of rubber. When I'm done, that just flops back over. It's quite sticky still, and it protects all of this connectivity over here from touching anything, for example. I'm going to do it is I'm going to double check if my wiring order is correct, because I don't want to peel all the wires loose. These three wires over here. So you have ground, you have data, and you have clock. So I did put it in the correct order: ground, data, and clock. So that will just make it easier for me to plug in these three wires next to each other. So that's ground, that's automatically data, and that's automatically clock. Obviously, if I switched around the yellow and the orange, which is clock and data, I would have had to switch it out over here as well. But the CP, it does tell you on the board: ground, data, and clock over there. So you can't make a mistake with the wiring. You just have to ensure that you plug it in correctly initially, otherwise you'll get reading errors, etc. Okay, nice. Next step is, as I mentioned before, cell voltages need to be above 3.5 each, and collectively for Mavic Pro specifically needs to be 10.5 volts minimum. These battery nominal capacities are, you can actually check it on the back. All of them have it listed on the back of the batteries. It's 11.4 volts. Not sure if you can see that. 11.4. And that gives you an indication of the maximum voltage that collectively these 3 cells are. So 11.4 divided by 3 cells. So what I like to do is I do max charge voltage is 30 volts according to the battery itself. The batteries are different, of course. So what I do is I put my power supply on 13 maximum. 12.5 also works because it's only going to charge to 11.4 anyway. And then I set my current for a sort of a fresh battery, unknown battery. I set it to at least 0.4, around there. You want to get the current, you don't want high current going through here if the battery's been laying in a cupboard or laying in storage for ages. So you would connect your positive lead. I obviously cleaned up the little glue that's on here already, and it's got the little rubber sponge, so it's protected from touching any components on the bottom. So I'll just add the positive clamp. I usually just give it a small touch in case there's a spark or arc for a capacitor, pulling voltage, and then I connect it. And if you have a look over here, you can see this battery is already fully charged. After it's reached that 11.4, 11.5 threshold, you can remove it, and then you can take it to the balance charger if you wanted to check each individual cell. Okay guys, another part of the process that is good practice to follow is having a balanced charger. The balanced charger is beneficial because it allows you to see the actual voltage of each cell. There are other ways. This is the sort of consumer friendly, easier way to do it. However, you do need to create yourself a balanced lead. As you can see, this is from an old Mavic Pro battery. Cut the wires off and I join ground. With ground over here, it actually gives you the indicator of all the pins. So you've got negative and then cell 1, 2 and 3. This obviously supports up to 6 cell BMSs. So in this case it's going to be a 3 cell, so it's 3 cells plus ground, 4 wires in total. You can see it's wired up already. I've got a couple of these for Phantom 4 Pro batteries, Mavic Pro batteries, Mavic 2, etc, etc. So I'm just going to pop this in and show you guys the different cell voltages on this specific battery, just to give you an idea of what it looks like. As you can see, these cells are, I mean, they could be balanced better. They're not too bad. 3.8 and 3.79 is in fact not too bad. Hope you guys can see that number on there. And then the third cell is 3.76, slightly lower, but still very usable. And you've got the resistance. This is very important. So I would not recommend using this battery because the resistance is above 20 milliohms. So anything above 20, in my opinion, it's not necessarily dangerous. It's just the higher resistance, the more heat it generates to charge and to discharge for that matter. So if you have a battery that shows 1, 5, 10, whatever the case may be, in that range, that's a good battery. So they tend to run a lot cooler than anything with high resistance. This battery will work, but it's not advised to use. As you can see, I've set it to 3 cell and it's 0.3 amp to slowly get voltage into these batteries. You do not want to give it 1, 2 or 3 amps. They can charge 3.5 amps from the original chargers. But if it was in storage, you want to give it a soft, very, very slow, full voltage, but extremely low current charge. And on these units, on this specific balance charger, you can adjust it from 0.1 all the way up to about 8 amps. So I would normally start at about 0.3, and I would say, as you can see there, it's starting to balance charge all 3 cells at a maximum of 0.3 amps. So it's going to take quite a long time for this battery to get full, but it's safe for all the cells because of the current being that low. That's it, guys. Thanks. Okay, guys. So I've got the CP soldered on correctly. Double check my wiring. I'm going to plug this into the laptop with the battery killer software running. I'm going to connect and I'm going to click on read information. So it's giving me this error, this specific error. There are only a handful of faults that causes a specific error. One of them being a bad solder job over here. Another one being incorrectly soldered wires or incorrectly plugged into the wrong place. On the CP, like I said, you make sure ground is ground, data is data, clock is clock. It's marked very clearly on the CP board as well as on the back of the Mavic Pro battery board, BMS. It's plugged in. So what I'm going to do is I'm going to attempt to switch it on, then do a read, because I know there's enough voltage to switch it on. I'm going to switch it off. So what I'm going to do is I just have to choose the right chipset over here. Click read, and there it reads. No more errors. Immediately within 10 seconds. You can see the cycle count shows 18. It shows you the voltage per cell. They are a little bit out. The first and second cell is not too bad. The third one's a little bit out. It's still usable, but you can do a balance charge on these cells if you. Once, excuse me, once you have read the info, it shows you chip is sealed. When you see this chip is sealed, you just have to click on unseal. The unseal will tell you it's successful. You click on clear PF. PF has been cleared. In other words, the permanent failure has now been removed. You click back on seal and it's done. It's officially done. It can be plugged into a charger. It'll be functioning. Again, all of this is entirely dependent on the health of your cells. I just want to add as well, if you have a look at the capacity and voltage area in the bottom of the software over here, do not mess around with these tabs and these options over here. This is specifically and exclusively used for changing the cycle count. It's exclusively used for replacing these old cells and brand new ones. It has to get calibrated. The firmware has to be all of these options, settings in the firmware will have to be changed as per the spec of the new replacement cells. It's not always identical. So max charge voltage, max end of charge voltage, things like that have to get changed. And in the case where you do replace cells with brand spanking new cells from the factory, brand new, you would change the cycle count to 0 because it's a brand new battery. The cycle count is an indication of age as well as actual quantity of charge cycles for cells, not the board, not the plastics, not the casing, specifically the cells. So please bear in mind, don't mess about with these settings. If you just want to clear the PF and get your battery that's been laying forever working again, all you need to do is click read info, unseal, clear the PF and seal in that order. And that's it. I think this one is ready to be put on charge.
Well guys, thanks for watching. Long video, but a lot of information, and that sort of information is really important. So if you guys do want the DJI Battery Killer version 2 software, I will leave a link in the description below. Guys, we're just asking, drop a small donation, whether it's $1, $2, $5, anything you see fit. Once you've made a donation, pop us an email to orders@webuydrones.co.za. I'll also leave that in the description below. And as soon as you've made a donation, you've emailed us, we will retransfer you the software. With that also comes support. Okay, so once you've got your software and you do battle, or you're struggling with something, or you have any technical questions, you have support via email. Okay, so I'll put Ashraf's email address in the description below. That'll be repairs@webuydrones.co.za. So you can hit him up via mail anytime if you do need support and you have technical questions. So appreciate it, guys. I hope the video was helpful. Until the next one, catch you guys later. Cheers.